In the previous video, we introduced the idea of 1D motion, which is motion along a straight line. We introduced displacement, and we also introduced distance. We did a few simple examples. Please check back. If you're not sure of all those ideas, it would be a good idea to watch that video and then come back into this one. So here we're going to introduce the idea of speed and velocity. First, let us introduce something called average speed. And you'll see why it's important to define average speed first, because later on we'll also define something called instantaneous speed. We'll do the same thing. We'll also define average velocity and then instantaneous velocity. So average speed is simply the rate at which an object or a particle covers a certain distance. Okay. Now, anytime we come up with the idea of rate, what you have to realize is we're talking about how it changes with respect to time. We will define average speed mathematically. We'll take this from this definition. We can write it mathematically as distance divided by time. Now, if you remember from the previous video, distance was the length of the path, and we realized that distance can always be positive. In a similar manner, average speed will always be positive. Average velocity is the rate of change of position. Now we already know what change in position is. So this quantity we know is simply displacement. So we can write average velocity, and we'll use the letter V and then AVG for that to say that it's average. And this is going to be equal to displacement divided by time. Displacement from the previous video we saw could be positive or negative. So average velocity could be positive or negative. And again, what we need to realize is that the sign in front of the average velocity once again gives you the effective direction of the motion. Negative would mean moving to the left, positive would mean moving to the right. So this is average velocity and average displacement. Now that we have average speed and average velocity, let us apply these ideas to a simple problem. Right. So in this problem, it says that a vehicle travels 1,000 meters due east, then travels 600 meters due west, and it completes this motion in 15 minutes. Question is, calculate the average speed and the average velocity for the entire motion. Okay. So would be a good time for you to pause the video and go ahead, solve the problem, and then come back and verify, whether you made a mistake or not. Right, so we're going to do this in two parts. We'll first find the average speed, and then we'll also do the average velocity. So the first part will be the average speed part. Now, we know what the definition of average speed is. In order to find the average speed, we need two things. We need the distance and we need the displacement. So this is equal to distance over the time. Sorry, not displacement. We need the distance and we need the time. Average velocity, on the other hand, we know is displacement over time. Okay, so it's in this particular situation, what we'll do is we'll draw a simple picture of what's happening. So let's say the vehicle started at some point and it traveled 1,000 meters to the east. So it went all the way and traveled, say, 1,000 meters. Okay, and then the vehicle came back another, say, 600 meters. Let us first use this picture to calculate the distance. Okay, distance happens to be length of the path, so the total distance traveled is equal to 1,000 plus 600. Okay, and then we divide this by the time, which happens to be 15 minutes, and what we need to do is we'll convert the time into seconds. So it'll be 15 multiplied by 60, and we end up with 1,600 divided by 900. Okay, and we can just write this as 16 over 9 meters per second. You can find the decimal equivalent of this. So very easy. Let's use the idea now to also find the average velocity. So V AVG is equal to, now if you look at this picture, let's find the displacement. Okay, if you remember displacement was the final position minus the initial position. If we call this initial position 0, then we realize that this object eventually ended at the 400 meter mark. So the displacement happens to be 400 meters. The time we've already calculated to be 900 seconds, and therefore the displacement is 4 over 9 meters per second. We knew that the average speed can only be positive. So this information essentially just tells us the average speed for the entire motion. The average velocity also has the hidden information of direction in it. Since the average velocity ends up being positive, we know that the object has ended somewhere to the right of where it started. If the same value had been negative, then we would have had the, that would have implied that the object has ended somewhere to the left of where it started. Okay? So hopefully that this clarifies at least how to apply things for, basically for this problem. Here's another problem. A particle moves due west at a speed of 10 meters per second for 15 minutes, then travels east at a speed of 8 meters per second for 10 minutes. Calculate the average speed and average velocity for the motion. Okay, so once again, this is not going to be a super hard problem. It's pretty straightforward, but slightly more involved than the previous one. So go ahead, stop, solve the problem, come back, and verify. Okay. So once again, what we'll do is we'll find out, we'll draw our information out and then use that to figure out the individual parts. Because once we have the individual distances, then the problem is pretty simple to complete. So first it says that the object traveled due west at a speed of 10 meters per second, and it does this for 15 minutes. Now, if you travel at a speed of 10 meters per second for 15 minutes, the distance that you covered in that part is going to be, and so let's call that distance S1. So that S1 is going to be equal to 10 meters per second multiplied by the time, which is 15, and then I'll also multiply that by 60 to convert it to seconds. So this ends up being 9,000 meters. But this is also 9,000 meters. Just let's make sure we remember it moves to the west. Now in the second part of the motion, S2, let's call this, it travels at a speed of 8 meters per second, does this for 10 seconds, and convert it to seconds, we'll multiply it by 60, and we end up with 4,800 meters due east. So once again, if we were to draw this picture, we have a particle travels, say 9,000 meters in this direction, and then it travels travels 4,800 meters in this direction. Okay, so we can now calculate the average speed and average velocity quite easily. Average speed is going to be equal to distance over time, and we know the distance, the total distance covered, is 9,000 plus 4,800, which is the length of the path, and we divided by the total time taken, and the total time taken was, in the first part it was 15 minutes, which converted to seconds gives you 900 seconds, and in the second part it was 10 minutes, which was converted to seconds gives you 600 seconds. And therefore the average velocity is going to be equal to average speed is going to be equal to 13800 divided by 1500, and we can just simplify this and just rewrite this as meters per second. Now on the other hand, the average velocity we know is displacement over the time interval, and displacement happens to be equal to, in this case, we know that the object has landed to the left, okay, of where it started, and you'll see that the displacement is simply negative 4,200 meters, and we can divide it by the time. The total time was still 1500 seconds, and this we can simplify negative 42 over 15, which could be simplified as negative 14 over 5 meters per second. So slightly more involved problem, but again the process is fairly simple once you diagram it, once you figure out the individual parts, and you obtain these answers. Okay, so hopefully that problem also kind of simplifies or makes you understand the process of applying the ideas a little better.